Welcome back to Building Tactics. In this video I'm building a 12 by 16 greenhouse. I'm going to show you the techniques I used from start to finish. Let's get started. First I excavate the site and then put down a layer of landscape fabric. I then put down about 3 or 4 inches of gravel and level it across. I put down 4x4s on each side and use the 4x4 to go from one side to the other, and I measure from the bottom of that 4x4 to the top of the gravel and try to get a consistent reading around 3.5, which is the height of the 4x4s. Next I take a 4x4 and I'm going to cut out a notch. This notch is for the corners so I can interlock the 4x4s for the base. I measure in 3.5 inches, which is the width of the 4x4. I then make a mark and then I measure down 1.75 inches, which is half the distance of the 4x4. This allows me to interlock the 4x4s together. This will make the 4x4s even. I place the two 12-foot 4x4s on the gravel, one on the front, one on the back. I turn the 4x4s to where the notches are up. I then measure the distance, 16 foot on each end. Next I place a 4x4 on the 16-foot side and I overlap the notches. This 4x4 is not a 16-foot long. The building supply place didn't have a 16-footer, so what I have to do is I have to piece together a 12-footer and a 4-footer. To make sure this is secure, I drill 2 holes in the ends of the 4x4s. The 12-foot 4x4 and the 4-foot one. I then put in about 8-inch piece of rebar in these 2 holes. I put the 2 pieces together. This will help reinforce the joint where the 2 pieces of 4x4 join. Next I used 3.5-inch screws to connect the corners together. Now that I have all the corners secured, I do a cross measurement to square up the base. I make adjustments until both measurements from corner to corner are equal. This will make the base square. Next I drill a 1/2-inch hole in the corners and I put a piece of 1/2-inch rebar, which is about 16 inches long, through the hole and into the ground. This helps hold the base, keeps it from moving. I do this on all 4 corners and then I measure every 4 foot down each side and I put a piece of rebar in at those points. Now that I have the base square and secure, I start laying out the top and bottom plate for the walls. We'll be putting the walls at 24-inch centers. So I start by measuring 23 1/4 inch from the outside corner, and then I go from there every 24 inches. This will allow my wood to break every 4 foot. Here I have a bottom plate that is shorter than the top plate, so I have to break it on a stud in the center of a stud and then add another piece of bottom plate. After I mark the locations of the studs, I take a framing square and mark each stud. So now I have all the studs laid out and marked on my top and bottom plate. I'm going to go cut the studs. My wall is a total of 80 inches, so I've subtracted the 4.5 for the 3 plates, and I'm going to be cutting my studs 75.5 inches. I did this for the material that I'm using. I'm going to be doing 32 inches of smartboard siding, and then from there 4 foot of the polycarbonate, which gives me a total of 80 inches for the total height of the wall. I did this to help save on material. I really didn't need an 8-foot wall, so I decided to do this to help with the material. So now I'm going to go cut the studs and lay them in place on each mark on this 12-foot wall. I have a total of 7 studs that I'm going to be putting down. I have the studs on 2-foot centers. The technique is the same if you use 16-inch center standard construction. The technique will be the same. Instead of doing 23 1/4 at the beginning, you'd do 15 1/4 and then 16 from there. As long as every 4 foot you're breaking center of your stud, your framing should work out. Once I have the walls raised, I level the wall and put on a 2x4 brace. I then secure the bottom plate to the base using 3.5-inch screws. I repeat this process on the other walls. Now I'm going to lay out the back wall, and normally I would start at 23 1/4 and then go 2 foot from there, but since we want our 4x8 panels to go
even with the outside. We basically have to go to the outside and measure in 23 1/4 and then go two foot from there. The easiest way to do that is to hook over the plate, the bottom plate, and then measure in 23 1/4. Put an X where the stud goes. Now at this point I can either put my end of my tape here and then measure 24 inches. But what I usually do, since I'm working by myself, is to step back 3/4 of an inch on each 2 foot measurement. Make my mark, put the X. And I do that all the way down the length of this wall. This is a 12-foot wall. And then at the end here, I'm going to mark that there's a stud that's going to go here. This stud will tie into this wall here. Normally, you would have a corner that would consist of at least 3 blocks, 2x4 blocks, or 2x4s, to make a corner to tie in to make it stronger. But in this case, there's not a lot of weight. It's not a very big building, so just 2x4 to tie into this 2x4 as a corner, I believe is sufficient. So from here, I'm going to mark on out to the end of the run. So now I have my standard 24-inch on center studs marked out. And before I go and use the square to mark the lines, this front wall has a 32-inch door. So I'm going to find the center of this wall and put a 32-inch door in it. So I know that this is a 12-foot wall, so I'm going to find 6 foot, and that's going to be my center. So my rough opening, I'm using the storm door, so the rough opening is actually 32 inches. So what I'll do is I'll come down here and I'll find 16, which is half the distance. So I have 16 inches on this side and 16 inches on the other side. It might be hard to see that because of that brace, but I'm making a line and I'm putting an X on the outside of the line. That represents the stud that's going to go here that the door is going to mount to.
So next I'm tying in the top plates. You want to go over the corner with the top plate to tie it all in. You don't want to break them on the same joint. If you go over it and screw it in, it secures it together. And then I take the other top plate on the other wall and butt it up to the top plate and secure it. I'm going to make sure it's even all the way down. And when I come to a joint, I make sure that it doesn't break. The top plate doesn't break on the joint. You want to overlap it and secure it real good with the screws on each side of the joint. And then I continue this process all the way around the building. Next, I lay out for the rafters. I used basically the same process as I did for the studs of the wall. I start out from the corner 23¼ inches and make a X on the 24-inch mark. That's where my rafter or truss is going to go. And then on one side of that, every 4 foot, I will be putting a rafter tie in. Next, I cut 2x4s to make trusses. This roof will have a 412 pitch, so I cut the 412 pitch on each end and then cut a bird's mouth that doesn't have a hangover. Next, I mark the center of a 8-foot piece of OSB. This is just temporary, and this line is going to be a guide for the top cut of the rafter. I line the rafter on the line on each side. I then secure it at the top with a screw. This is to hold it in place while I make adjustments to make sure the truss is going to be the right width. Next, I measure from one end of the truss to the other, and I make sure that I have 12 feet. Once I have the rafters at the right length and angle, I use one of them to make a pattern for each side. I lay it on each of the 2x4s and mark it. This will ensure that all the rafters are the same length and the angle are the same. Next, I put a centerpiece in to secure the center of the truss. Now I have to make sure all the walls are in line. I do this by measuring in 5 inches from the corner and making a mark. I then put a notch at the corner of the top plate on this mark, and just below the notch I put in a screw. I will tie a string line to the screw and put the string in the notch. And I measure all the way down the length of the wall to make sure I have 5 inches to that mark. I do this on both sides. I then place the rafter ties on the top plate on the 4-foot marks and secure them with 3-inch screws. After that, I install a temporary 2x4 block in the center of the back wall, and I put the truss up and secure it to the temporary 2x4. This 2x4 holds the truss in place while I secure it. Next, I install 2x4 blocking in between each truss. I start from the first truss to the second truss with a 21¾ inch 2x4 on each side of the ridge. Then each blocking after that is 22½ from one truss to the other. I do this to the end. The last truss will be a different measurement also. The best way to get this measurement is measure from the last truss to the inside of the second truss from the end at the top plate. Next, I install blocking in between each truss at the halfway point on each side. This is going to be used for a nailer for the polycarbonate. This is what it should look like when you have all the blocking in place and the gable end framed in. Next, I install blocking at the 32-inch mark. This is for a nailer for the bottom of the polycarbonate and the top part of the smartboard siding. Next, I'm going to put a fascia piece on to cover the ends of the rafter ties and rafters. This will also be the piece that the polycarbonate will butt up to. So I start by finding the center of the 2x6 and I make a line. I'm going to make a angle on each of these pieces to allow the polycarbonate to come down over top of the fascia piece. So I take my square and I find the angle that in degrees that matches the roof pitch, and I make a mark on the end. This is just temporary. This is so I can measure how wide this angle is going to be. I take half that distance and I go from the center line and make a mark. I then mark this distance all the way down the board. Next, I adjust the saw to the degrees that I came up with. This is for the roof pitch. Now I make the cut all the way down the board, and after this cut is done, I should have two pieces that are identical. Now I have two pieces that are identical. They have the same pitch and are the same width. I screw the fascia piece in to the rafters, and I use my speed square to make sure that it's not up too high to interfere with the polycarbonate hanging over. Next, I frame the gable end for a 14 by 14 fan. There's going to be one on each end of the greenhouse, and I basically take 2x4s and cut the angle on one end and screw it in to the top and the bottom, and I'll run a piece across the top also to give it the same depth on the top and the bottom of the opening. Next, I put a couple coats of paint on the framing that's going to be exposed by the polycarbonate. You can just leave it unpainted, but we decided to go with white frames. That way When you see through the polycarbonate, you're going to be seeing the framing white. If we could leave it just bare, but you will be seeing the bare wood through the polycarbonate. And we think we decided to go this way because we thought it would look better from the outside looking at the greenhouse rather than having exposed wood. I put 2 coats of paint on all the framing that's going to be exposed to the polycarbonate. Next, I level all the corners to verify that they are still level before I put the smart siding and the polycarbonate on. Next, I chalk a line at the 32-inch mark all the way around the building. This line is where the top of the smart siding is going to go. Next, I'm going to cut the smart siding to 32 inches. I will end up with 3 different 32-inch pieces out of 1 piece of smart siding. Put a screw in the corner and to hold several pieces together so I can make one cut and cut multiple pieces at a time. So before I install the smart siding, I'm going to put a couple coats of paint on it. Here I'm painting the bottom and top edges. This will help with water penetration. It seals off the ends. I paint each piece 1 coat and then let it dry and then put the second coat on. Now that the siding's ready to install, I just simply start on the corner, get it even on the corner, and bring the top of the smart siding up to the chalk line, and I screw into the studs and into the top brace and the bottom plate. Here I'm using 1.25 inch screws. They are gray, but I'll simply just go back when I touch up the siding and paint over these screws so they're not visible. On this front I have a door, so I put another piece on the other corner and secure it in, and then I'll have to put a small piece on each side of the door. On the back wall, I start on one corner and I work my way to the right. I have this smart siding positioned to where the next piece will overlap the first piece, and I continue this pattern to the corner. Now it's time to start installing the polycarbonate. On the bottom edge of the polycarbonate, it has a U-channel piece. And on this piece, you need to drill an 1/8 inch hole about a foot apart. And this is to allow any moisture or water to seep out of and away from the polycarbonate. And on the top edges of the polycarbonate, you use a foil tape to seal off the top. This particular polycarbonate has a UV protectant on one side, and it's the side that has the film or the white strip running up and down. You want to remove this before you put it on. That way, when you put your screws in, you don't have to worry about the film being in behind your screws. And this is the side of the polycarbonate that will be facing on the outside of the greenhouse. To secure the polycarbonate to the frame, I'm using 2-inch screws that are designed for this polycarbonate. They have a larger washer with a gasket on it to help hold the polycarbonate in. I also painted the head of the screws white to match the frame so they're not as visible. You will also want to pre-drill your screw holes. This is to keep from damaging the polycarbonate. If you try to screw it in without pre-drilling, you're more likely to cause damage to the polycarbonate. It's also a good idea to adjust the torque on your drill to where it doesn't sink the screws too far. This could cause damage to the polycarbonate if it's screwed in too far. On the roof, I put screws on the cross braces that I put in for the rafters, and I also screw the bottom where the fascia board is. To seal the seams on the roof between the panels, I'm using a 1/8 inch PVC. It's a lattice trim piece, and I put butyl tape on it to seal the seams. I take this piece with the tape and I press it into the seam, and then I screw screws about 12 inches to 16 inches apart along this PVC piece. Next, I install a ridge cap. This is basically a piece of scrap aluminum trim that I had. I bent the angle to fit the pitch of the roof, and I screw this up with the screws, and where the trim pieces are, I put a screw on each side of it to help hold it down. This keeps water from getting in the ridge. In order to install the ridge cap, I had to get on the roof, so I took a piece of plywood and I put it over the polycarbonate, and making sure it's over a couple rafters, and I temporarily secured the bottom of it with a couple screws. At this point, I could tell that the roof was going to hold pretty good because there was no sway or no give when I got on top of the roof, so I'm pretty confident that this roof system will work on this size building. Next, I'm going to install a vent on the gable end. There's one on each end of the greenhouse. The one on the back actually will have a fan. I'm going to do a separate video on how to do the solar fan setup on the greenhouse. So I cut out the polycarbonate and I install the gable vent. I also put on a little bit of butyl tape around the vent. This is to keep water from getting in around the edges of the vent. On this greenhouse, I decided to use a 32-inch storm door. This door has a glass that can open and close, and it has a screen to allow air to flow through. So I started to install the door by attaching the hinge rail, and as you can see here, this storm door was designed to be put on an exterior door, so it's a little bit different setup to put it on this greenhouse because the polycarbonate and the smart siding is different thicknesses. So I have to take the edge of the door and slide it in behind the polycarbonate and the smart siding, and then secure it to the frame. Once I have it behind the polycarbonate and the smart siding, there's a small screw that I installed that this rail will rest on. Once I have it on that screw, then I can line the door up and secure it to the frame. This is a much different process than installing a storm door on an exterior door. It makes it more difficult to install because you're working with a door that technically wasn't designed for this, but it does work well. Next, I install the top flashing trim, and basically it goes underneath the polycarbonate and over top of the rail that the door is on. Then I secure it with a couple of screws. I secure the other side rail in the same manner. I put it in behind the polycarbonate and the smart siding and secure it with screws. Before I secure it, I check to make sure that the door is going to close and that the gap between the door and the frame is correct. To install the door latch, I use a template to mark out the holes that I'm going to drill. These holes are for the screws and the actual latch. As you can see here, there's a distance between the door latch and the wood frame. Because this door was designed for an exterior door, you have about 3/4 inch difference between the frame of the greenhouse and where the door latches could be mounted to. So to compensate for this, I put a couple of the PVC shims. You could also use a 3/4 inch piece of wood. This is just what I had laying around. And I secure it into the wall and attach the latch. This piece goes on the bottom to help seal off the air for an actual door. I'm going to be putting landscape block down to make a flat surface for the door to close, and then I'll put this piece on. Next, I'm going to install a workbench. It's going to be 2 foot wide, and it's going to go around both sides of the greenhouse and the back. It's going to be made out of treated lumber because there's going to be water used here, and over time, if I used regular lumber, it would probably affect the lumber. So I start by laying out 2 foot centers, and I'm going to take these 2x4s and put basically 2x4 blocking in between them, and then put the 5/4 decking over top of that. This is basically using standard framing techniques on 2 foot centers. The 2x4 blocks are 21 inches long, and that would give me 24 inch total for the bench. So to make it easier to install this by myself, I measured down 3.5 inches from my chalk line, and I put a couple of screws along the wall. These screws will help hold the bench frame in place while I secure it to the wall. I use a piece of 2x4 with angles cut on each end to brace the bench. I run the 2x4 from the bottom plate up to the front of the bench and secure it with screws. I will put these braces on at every 4 foot. So the material I used for this bench came up a few feet short on the bench run. So I'll build a small section and secure it on the end stud from the last section I built. I repeat this process on the other wall. It's important to use a level to level the bench and then secure the brace. On the back wall, I end up with a bench that's approximately 8 foot long. It's the same technique as the other two benches. Secure it to the back wall and then to each of the side benches, and I'll put a couple braces in to give it more strength. Next, I use 5/4 decking to make the top of the bench. I stagger my joints on each run and secure it with a couple screws on each stud. Okay, there you go. That's how I put together this 12 by 16 greenhouse. If you can, like this video and subscribe to the channel so we can continue to make these videos. And thanks for watching Building Tactics.